Good morning, my dear students. Now today, in this video clip, we discuss about the capacitor. What is capacitor? Already you know that is the capacitance of the spherical conductor. Yes. Now the spherical conductor of radius r. Now it is a charged with a charge that is Q and its potential is V. Charged with the charge and its potential V. Then the capacitance of this conductor is measured by the ratio of the charge to the potential. Then in the previous video clip, that capacitance of the spherical conductor you got 4 pi epsilon naught into capital letter R. Now, what is the C here? Capacitance. What is epsilon naught? Permittivity of the free space. What is our radius of the spherical conductor? And one more point in the previous video clip, that conductor depends upon the capacitance of the conductor depends upon what are the factors. First one it depends on nature of the conductor and size and shape of the conductor, and that is surrounding medium and neighboring conductor. The neighboring conductor is very important point. ಏನೋ ಬೇರೆ ಒಂದು ಕಂಡಕ್ಟರ್ ಹತ್ರ ತಗೊಂಡ್ರೆ ಇದರ ಕೆಪಾಸಿಟನ್ಸ್ ಏನಾಗುತ್ತದೆ? ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತದೆ. ಅದು ಸ್ಟೋರಿಂಗ್ ಕೆಪಾಸಿಟಿ ಆಫ್ ದ to store the charge ಏನಾಗ್ತಾ ಹೋಗ್ತದೆ, ಹೆಚ್ಚಾಗುತ್ತಾ ಹೋಗುತ್ತೆ. ನಾವು ಏನ್ ಮಾಡೋಣ, ಅರ್ತ್ ಅನ್ನ ಕಂಡಕ್ಟರ್ ಅಂತ ತಗೊಂಡು ಅರ್ತ್ ಇಸ್ ಅ ಕಂಡಕ್ಟರ್ ತಗೊಂಡು ಅರ್ತ್ ಇಸ್ ಎ ಕಂಡಕ್ಟರ್ ಅಂತ ತಗೊಳ್ಳೋದು. ಅರ್ತ್ ಕಂಡಕ್ಟರ್ ತಗೊಂಡ್ರೆ ಆರ್ ಏನಾಗುತ್ತೆ 6.4 ಇಂಟು 10 to the power of 6,400 kilometer. This is 6.4 into 10 to the power of 6 meter. Why? Because R is radius of the earth near about 6,400 kilometer. Kilo 10 raised to 3. Point ಇಲ್ಲಿ ಬಂದು ಮತ್ತೆ 10 raised to 3, 10 raised to 6 meter. Now I substitute here. What you got to see here? Radius. Now C you have to substitute here. What you got here? C is equal to 4 pi epsilon naught. 4 pi epsilon naught 1 by 4 pi epsilon naught value, how much you got? That is, how much you got? 9 into 10 to the power of 9. 9 into 10 to the power of 9. Now, what is 4 pi epsilon naught? 4 pi epsilon naught value. This is 1 by 9 into 10 to the power of 9. Now, 6.4 into 10 to the power of 6 divided by 9 into 10 to the power of 9 you got. C is equal to 6.4 into 10 to the power of minus 3 you got. Divided by 9. I think it is you divide this one. Suppose if you divide this one, what you got the value? I think it is near about 0.711 into 10 to the power of minus 3 farad. And now see about this one. Now that capacitance is near about 711 into 10 to the power of minus 6 farad. Now it is near about 711 microfarad. Microfarad. ಅಂದ್ರೆ ಅರ್ಥನ ಕಂಡಕ್ಟರ್ ಅಂತ ತಗೊಂಡ್ರೆ ಅದ್ರ ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟು ಬರುತ್ತಾ? 711 ಮೈಕ್ರೋಫರಡ್ ಬರುತ್ತೆ. ಸಪೋಸ್ ಕೆಪಾಸಿಟನ್ಸ್ ಸಿ 1 ಫರಡ್ ಇರಬೇಕಂದ್ರೆ ಆರ್ ಎಷ್ಟಿರಬೇಕು ಅಂತ. ಆರ್ ಎಷ್ಟಿರಬೇಕು? ಸರಿ, ಈ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಇದು 1 ತಗೊಂಡು 1, ಆಮೇಲೆ ಇದು 4 pi epsilon naught ಆರ್ ತಗೊಂಡು ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್ ಯು ಗಾಟ್ 1 by 4 pi epsilon naught 1 upon 4 pi epsilon naught meter. What is you got? R is equal to 9 into 10 to the power of 9 meter. It means R is equal to about 900 into 10 to the power of 6 meter. Radius how much you hear? 6.4 into 10 to the power of 6 meter for the earth. but this conductor is 900 into 10 to the power of 6 meter. It means ಇಲ್ಲೇನಾಗುತ್ತೆ, ಅರ್ಥನಲ್ಲಿ ಕಂಡಕ್ಟರ್ ತಗೊಂಡ್ರೆ ಅದ್ರ ಕೆಪಾಸಿಟನ್ಸ್ 711 ಮೈಕ್ರೋಫರಡ್ ಬರುತ್ತೆ. 1 ಫೆರಡ್ ಇರ್ಬೇಕ ಕೆಪಾಸಿಟನ್ಸ್ ಅಂದ್ರೆ ಕಂಡಕ್ಟರ್ ಎಷ್ಟು ದೊಡ್ಡದಿರ್ಬೇಕು. ಕಂಡಕ್ಟರ್ ಎಷ್ಟು ದೊಡ್ಡದಿರ್ಬೇಕು ಅಂದ್ರೆ 9 into 10 to the power of 9 meter ರೇಡಿಯಸ್ ಇರ್ತಕ್ಕಂಥ ಕಂಡಕ್ಟರ್ ಬೇಕು. ಅಂದ್ರೆ 900 into 10 to the power of 6 meter ಇರ್ತಕ್ಕಂಥದ್ದು. ಇದು ಎಷ್ಟದ, ಇದು ಎಷ್ಟು ಅಂತಂದ್ರೆ ಇಟ್ ಇಸ್ ನಿಯರ್ ಅಬೌಟ್ ಹೌ ಮೆನಿ ಟೈಮ್ಸ್ 100 in terms of 900 times. 100 times is greater. Size of the conductor 100 times greater than the earth ಇರಬೇಕು. earth ಗಿಂತ 100 ಪಟ್ಟು ದೊಡ್ಡದಿರ್ಬೇಕು. ಅವಾಗ ಅದರ ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟಿರುತ್ತೆ, 1 farad ಇರುತ್ತೆ. Now it is very difficult to construct such a type of conductor to store the electric charges. At that time you construct a new device that is said to be capacitor. What is capacitor? Capacitor is the device. It is used to store the electric charge or electric potential energy. What is capacitor? In the capacitor there are two identical conductors. Identical means ಎರಡು ಪ್ಯಾರಲ್ ಇದ್ರೆ ಎರಡು ಪ್ಯಾರಲ್, ಎರಡು ಸ್ಪೆರಿಕಲ್ ಇದ್ರೆ ಎರಡು ಸ್ಪೆರಿಕಲ್ ಕಂಡಕ್ಟರ್, ಎರಡು ಸಿಲಿಂಡ್ರಿಕಲ್ ಇದ್ರೆ ಎರಡು ಸಿಲಿಂಡ್ರಿಕಲ್ ಕಂಡಕ್ಟರ್ಸ್, ಹಾಲೋ ಸಿಲಿಂಡ್ರಿಕಲ್ ಕಂಡಕ್ಟರ್. ಈ ತರ ಇವಾಗ ಇದು ಏನು ಅನಿಸ್ಕೊತದೆ, ಪ್ಯಾರಲ್ ಪ್ಲೇಟ್ ಕೆಪಾಸಿಟರ್, ಇದು ಪ್ಯಾರಲ್ ಪ್ಲೇಟ್ ಕೆಪಾಸಿಟರ್, ಇದು ಸ್ಪೆರಿಕಲ್ ಕೆಪಾಸಿಟರ್, ಇದು ಏನು ಅನಿಸ್ಕೊಳ್ತದೆ, ಸಿಲಿಂಡ್ರಿಕಲ್ ಕೆಪಾಸಿಟರ್ ಅನಿಸ್ಕೊಳ್ತದೆ. Now take a parallel plate capacitor. Now there are two identical conductors A and B and insulated here. Now it is separated by very small distance here D. Separated by very small distance. In any capacitor, one of the conductor is charged with the charge what you say plus Q and another conductor is charged with the charge minus Q. ಇದು ಎಷ್ಟು ಚಾರ್ಜ್ ಇರುತ್ತದೆ, ಇದು ಅಷ್ಟೇ ಚಾರ್ಜ್ ಇರುತ್ತದೆ ಕೆಪಾಸಿಟರ್. ಇವು ಎರಡರ ಮಧ್ಯೆ ಇರತಕ್ಕಂಥ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ P. ದೆನ್ ಈಗ now it is it store the more charge in the small space. ಕೆಪಾಸಿಟರ್ ನಾವು ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡೋ ಉದ್ದೇಶ ಏನು ಅಂತಂದ್ರೆ ಸ್ವಲ್ಪ ಸ್ಪೇಸ್ ನಲ್ಲಿ ಹೆಚ್ಚಿನ ಚಾರ್ಜ್ ಏನ್ ಮಾಡ್ಕೋತದೆ, ಸ್ಟೋರ್ ಮಾಡ್ಕೋತದೆ. ಇದನ್ನ ಬಿಟ್ಟು ನಾವು ಕಂಡಕ್ಟರ್ ಬಿಟ್ವಿ ಅಂದ್ರೆ ಬಿಟ್ಟು ಹಾಕಿದ್ವಿ, ನಾವೇನ್ ಮಾಡಿದ್ವಿ ಕೆಪಾಸಿಟರ್ ಬಂದ್ವಿ ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಸ್ಪೇಸ್ ಒಳಗೆ ಹೆಚ್ಚಿನ ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಮಾಡ್ಕೊಳ್ತೇವೆ. ಇದು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್. ನಾವು ಕೆಪಾಸಿಟನ್ಸ್ ಆಫ್ ದಿಸ್ ಕೆಪಾಸಿಟರ್ ಇದು ಯಾವಾಗಲೂ ಅರ್ತ್ ಕನೆಕ್ಟ್ ಇರಬೇಕು, ಒನ್ ಕಂಡಕ್ಟರ್. ನಾವು C is equal to Q divided by V. ಏನಿದು the magnitude of the charge on either plate of the capacitor divided by potential difference. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ P 1 volt ಇದ್ರೆ C is equal to Q. Now capacitance of the capacitor is defined as the amount of charge is required to raise its potential difference between the two plates by 1 volt. Capacitance of the capacitor is defined as the amount of charge is required to raise the potential difference by between the two plates by 1 volt. Capacitance of the conductor ಬೇರೆ, capacitance of the capacitor definition ಬೇರೆ. ಇವಾಗಿಲ್ಲ if Q is equal to 1 coulomb ಕೊಟ್ಟಿದ್ದೀವಿ, P is equal to 1 volt ರೈಸ್ ಆಯಿತು, then C is equal to 1 farad. Now capacitance of the capacitor is said to be 1 farad. If 1 coulomb charge is given to either plate of the capacitor, change its potential difference by 1 volt. This is the definition of what you say capacitance 1 farad of the capacitor. Once again I repeat, ಕಂಡಕ್ಟರ್ ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಮಾಡಲಿಕ್ಕೆ ಬಹಳ ದೊಡ್ಡದಾಗಿ ನಾವು ಗಾತ್ರದಲ್ಲಿ ತಗೋಬೇಕಾಗುತ್ತೆ. ಅದರ ಬದಲಾಗಿ ಸ್ವಲ್ಪ ಸ್ಪೇಸ್ ನಲ್ಲಿ ನಾವು ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಮಾಡಬೇಕಂದ್ರೆ ನ್ಯೂ ಡಿವೈಸ್ ಹೋಗ್ತೀವಿ, ಅದೇ ಕೆಪಾಸಿಟರ್. ಯಾಕಂದ್ರೆ ಯಾವ ಪಾಯಿಂಟ್ ಅಪ್ಲೈ ಮಾಡ್ತಾನೋ ಕಂಡಕ್ಟರ್ ಇರ್ತಿರಲ್ಲ, ಅದನ್ನ ಇನ್ನೊಂದು ಕಂಡಕ್ಟರ್ ಹತ್ರ ತಗೊಂಡು ಬಂದಾಗ ಇದ್ರ ಕೆಪಾಸಿಟನ್ಸ್ ಏನಾಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಕಂಡಕ್ಟರ್ ಎ ಹತ್ರ ಇನ್ನೊಂದು ಕಂಡಕ್ಟರ್ ಬಿ ತಗೊಂಡು ಬಂದಾಗ ಅದ್ರ ಕೆಪಾಸಿಟನ್ಸ್ ಹೆಚ್ಚಾಗುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು ನ್ಯೂ ಡಿವೈಸ್ ಹೋಗ್ತೀವಿ. ಆ ಡಿವೈಸ್ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಕೆಪಾಸಿಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಥ್ಯಾಂಕ್ ಯು. ಗುಡ್ ಮಾರ್ನಿಂಗ್ my dear students. In this video clip we discuss about the capacitance of parallel plate capacitor. In previous video clip, what is the meaning of capacitance, what is the capacitor, what is the capacitance of the that is a capacitor, you know already this point. And there are different types of capacitors. It is based on shape of the two conductors. If the two plates are parallel, then it is said to be parallel plate capacitor. This parallel plate capacitor it may be rectangular plates, square plates, or you said to be circular plate, whatever it may be in parallel plate capacitor. If the two identical conductors are spherical, then it is said to be spherical capacitor. If the two conductors are in the cylindrical shape, then it is said to be cylindrical capacitor. ಇದಕ್ಕೆ ನಾವು cylindrical capacitor ಅಂತ ಹೇಳ್ತಾರೆ. ಇದು ಯಾವಾಗಲೂ ಅವತ್ತು ಕನೆಕ್ಟರ್ ಬೇಕು. In the case of parallel plate capacitor, there are X and Y are the two parallel plates, each of surface area A. They are separated by the distance D, and the conductor Y, plate Y, is connected to the earth. Here A is charged with a charge plus Q, and X is charged with a charge plus Q, and the conductor Y charged with a charge minus Q. Its surface charge density is plus sigma, its surface charge density is minus sigma. These two charges are equal. Suppose it is plus 2 microcoulomb, definitely it is minus 2 microcoulomb. Like that, the charges are same here. Both the plates are charged equally. Now, electric field between the two plates is said to be E, between the two plates. It is a uniform well inside the space between the two plates of the capacitor. At axis it is a non-uniform. Now, electric field between two plates. ಇವಾಗ ಏನದ ಈ ಪ್ಲೇಟ್ ನಿಂದನೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಬರುತ್ತೆ, ಈ ಪ್ಲೇಟ್ ನಿಂದನೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಬರುತ್ತೆ, ಎರಡು ಬರುತ್ತೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಈ ಪ್ಲೇಟ್ ನಿಂದ ಬಂದಿರತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್, ಈ ಪ್ಲೇಟ್ ನಿಂದ ಬಂದಿರತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎರಡು ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ಪ್ಲೇಟ್ ಎಕ್ಸ್ ದಿಂದ ಬಂದಿರತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಸಿಗ್ಮಾ ಅಪಾನ್ 2 ಎಪ್ಸಿಲಾನ್ ನಾಟ್, ಪ್ಲೇಟ್ ವೈ ದಿಂದ ಬಂದಿರತಕ್ಕಂಥದ್ದು ಸಿಗ್ಮಾ ಅಪಾನ್ 2 ಎಪ್ಸಿಲಾನ್ ನಾಟ್, and E is equal to 2 sigma upon 2 epsilon naught. 2 cancel here, sigma by epsilon naught, equation number 1. It is the electric field between the two plates of the capacitor. Now, according to surface charge density, this Q divided by A, charge per unit area, the sigma, substitute here sigma Q by A, Q by epsilon naught A, equation number 2. Then by relation between electric field and electric potential, that is E is equal to P by D. Now we say equation number 3. Equate these two equations. Equate equation number 2 and equation number 3. That is P upon D is equal to Q divided by epsilon naught A. Okay. Therefore, P divided by Q is equal to what to take here? D divided by epsilon naught A. Reciprocal of this one, Q by V is equal to epsilon naught A divided by D. This is your equation number 4. By definition of capacitance, what is a C is equal to Q by V. Therefore, C is equal to epsilon naught A divided by D. Now this is the equation number 5. This is the equation of the capacitance of the parallel plate air capacitor. Air means it is filled with the air here in between the two plates of the capacitor. It is filled with the air. Therefore, capacitance of the parallel plate capacitor is equal to epsilon naught A divided by D. Now, if it is filled with this is for air. It is filled with other than air medium. C is equal to epsilon naught into epsilon R into A divided by D, equation number 6. It is the equation for the capacitance of the parallel plate capacitor, and dielectric is filled with there is a dielectric field between the two plates of the capacitor. Now, how they related? Now see here, capacitance of the parallel plate capacitor directly proportional to area of the east plate of the capacitor. When A is increases, C is increases, and it is inversely proportional to spacing between the or distance between the two plates of the capacitor, and it is proportional to dielectric constant of the medium. How it is increased? The capacitance of the parallel plate capacitor is increased by increasing by area of the plates of the capacitor, and it is increased by high electric constant medium used between the two plates of the capacitor. It is increased by decreasing the space between the two plates of the capacitor. This is about the parallel plate capacitor. It is very important for the examination purpose. It is asked in the examination for 3 mark, or relation it is over 2 mark, or is said to be 1 mark. Thank you. Good morning, my dear students. In this video clip, I want to discuss about combination of capacitors. Now already you know in the previous video clip what is capacitor. There are different types of capacitors, but here you have to take parallel plate capacitor. Any type of capacitor you have to take. Here, what is the circuit symbol of the capacitor? The circuit symbol of capacitor is like this. ಎರಡು ಲೈನ್ ಈಕ್ವಲ್ ಆಗಿ ಡ್ರಾ ಮಾಡಿ ಇದು ಸಿ ಅಂತ ಬರೀತೀವಿ. ಇದು ಕೆಪಾಸಿಟರ್ ಸಿಂಬಾಲ್. ಇದು ಫಿಕ್ಸ್ಡ್ ಕೆಪಾಸಿಟನ್ಸ್ ಅಂದ್ರೆ ವ್ಯಾಲ್ಯೂ ಫಿಕ್ಸ್ಡ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 4.4 ಮೈಕ್ರೋಫರಡ್ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಫಿಕ್ಸ್ಡ್ ಅಂದ್ರೆ ಚೇಂಜ್ ಆಗಲ್ಲ. ಸರ್ಕ್ಯೂಟ್ ನಾಗ ಇನ್ನೊಂದು ತರ ಇರ್ತದ. ಕೆಪಾಸಿಟರ್ ಎರಡು ಲೈನ್ ಈಕ್ವಲ್ ಇರಬೇಕು, ತೀರಾ ದೂರ ಇರಬಾರ್ದು, ತೀರಾ ಹತ್ರನೂ ಇರಬಾರ್ದು. ಈ ಸೈಜ್ ಮೇಲೆ ಈ ಸೈಜ್ ನೋಡ್ಕೊಂಡು ಡಿಸ್ಟೆನ್ಸ್ ಸ್ಪೇಸಿಂಗ್ ಇರಬೇಕು. ದಿಸ್ ಇಸ್ ಸೆಡ್ ಟು ಬಿ ವೇರಿಯೇಬಲ್ ಕೆಪಾಸಿಟರ್. ದಿಸ್ ಇಸ್ ದ ವೇರಿಯೇಬಲ್ ಕೆಪಾಸಿಟರ್. ನಾವು ಇದ್ರ ಮೇಲೆ ಒಂದು ಲೈನ್ ಇರುತ್ತೆ. ದಿಸ್ ಇಸ್ ದ ವೇರಿಯೇಬಲ್ ಕೆಪಾಸಿಟರ್. ಅಂದ್ರೆ ಕೆಪಾಸಿಟನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಫಿಕ್ಸ್ ಇರಲ್ಲ. ಇದಕ್ಕೆ ನಾವು ಗ್ಯಾಂಗ್ ಕೆಪಾಸಿಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಇನ್ನೊಂದು ವೇರಿಯೇಬಲ್ ಕೆಪಾಸಿಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸರ್ಕ್ಯೂಟ್ ಸಿಂಬಾಲ್ ಈ ತರ ಇರುತ್ತೆ. ದಿಸ್ ದ ಸರ್ಕ್ಯೂಟ್ ಸಿಂಬಾಲ್ ಆಫ್ ದಿ ಕೆಪಾಸಿಟರ್. ಎನಿ ಟೈಪ್ ಆಫ್ ಕೆಪಾಸಿಟರ್, ಮೇ ಬಿ ಪ್ಯಾರಲಲ್ ಪ್ಲೇಟ್ ಕೆಪಾಸಿಟರ್, spherical capacitor, or is said to be cylindrical capacitor. But in your syllabus, only you study that is parallel plate capacitor. There are 2 plates. Fine, okay. Now, such type of so many capacitors are there. 2 or more than 2. Yes. Now, combination of capacitors. The 2 or more capacitors are connected in the different types of combination. What are the types of combination of the capacitor? One is parallel combination, series combination. Another one is parallel combination. Fine. What is series combination of capacitors? In your study, it is only for 2 capacitor combination is there. 2 capacitor ಮಾತ್ರ ತಗೊಳ್ಳೋದು ನಿಮ್ಮ ಸಿಲೆಬಸ್ ನಲ್ಲಿ ಇರೋದು. ಅದು ನಾವು ಮೋರ್ ದನ್ 2 capacitor ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರುತ್ತೆ. ಓಕೆ. Series combination. What is the meaning of 2? If the 2 capacitors are connected end to end, ಅಂದ್ರೆ ಇದರ ಎಂಡ್ ಇದಕ್ಕೆ ಮತ್ತು ಇದರ ಎಂಡ್ ಫ್ರೀ ಇರುತ್ತೆ, ಇವೆರಡು ಫ್ರೀ ಇರ್ತವೆ. They are end to end by applying the potential difference. This combination is called series combination of the capacitors. Once again I repeat, 2 or more capacitors, here you take 2 capacitors, are connected end to end by applying the potential difference. This is called series combination of capacitors. Now C1 and C2 are the capacitances of the 2 capacitors. They are connected in series. Ps is the potential difference applied across the series combination. Then charge Q is the charge on either plate of the capacitor. Now this is the equivalent circuit. Either equivalent iru andre idu enagutte equivalent capacitance. What is equivalent capacitance? Equivalent capacitance is that single capacitance give the effect same as the effect given by the series combination of 2 capacitors. Once again I repeat, the equivalent capacitance is that single capacitance give the effect same as the effect given by the series combination of the 2 capacitors. CS is said to be equivalent capacitance. Then capacitor is said to be equivalent capacitors. Now, in series combination, there are very important 2 points in the series combination. What is the points? In series combination, charge is same. Charge on either plate of each capacitor is same. ಅಂದ್ರೆ ಇಲ್ಲಿ +2 ಕೂಲಂಬ್ ಇದ್ರೆ ಇದು -2, ಇದು +2 -2. ಎಷ್ಟೆಲ್ಲ ಕೆಪಾಸಿಟರ್ ಇರಲಿ, ಚಾರ್ಜ್ ಆನ್ ಐದರ್ ಪ್ಲೇಟ್ ಆಫ್ ದಿ ಕೆಪಾಸಿಟರ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮಾತ್ರ ಸೇಮ್ ಇರುತ್ತೆ. ಎರಡನೇ ಪಾಯಿಂಟ್, ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಈಸ್ ಡಿಫರೆಂಟ್. ಅಂದ್ರೆ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇದಕ್ಕೆ ಎಷ್ಟು ಡ್ರಾಪ್ ಆಗಿದೆ, ಇದಕ್ಕೆ ಎಷ್ಟು ಡ್ರಾಪ್ ಆಗಿದೆ, ಏನಿರ್ತದೆ, ಬೇರೆ ಬೇರೆ ಇರುತ್ತದೆ, ಬೇರೆ ಬೇರೆ ಇರುತ್ತೆ. ಕೆಪಾಸಿಟರ್ಸ್ ಬೇರೆ ಬೇರೆ ಕೆಪಾಸಿಟರ್ಸ್ ಇದ್ರೆ ಇದು ಕೂಡ ಬೇರೆ ಬೇರೆ ಇರುತ್ತದೆ. ಸಪೋಸ್ ಅಕಸ್ಮಾತ್ ಈಗ ಕೆಪಾಸಿಟರ್ಸ್ ಈಕ್ವಲ್ ಕೆಪಾಸಿಟರ್ಸ್ ಇದ್ರೆ ಸೇಮ್ ಇರಬಹುದು, ಬಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಕ್ರಾಸ್ ದ series combination of capacitor is different. Is the very two important points. Yes, then potential difference across series combination of the capacitors, that is said to be PS. PS is the potential difference across series combination of the capacitors. Now this is equal to potential difference across the series combination is equal to sum of the potential differences across individual capacitors. ಈ potential ಕೂಡಿಸಿದ್ರೆ ಈ potential ಸಿಗುತ್ತೆ. Then by definition of capacitance, C is equal to Q by V. Yesterday in the previous video already you know this one. Then P is equal to what you got, Q by C. Then potential difference across C1, you got P1 is equal to Q by C1 according to this one. Q is same. Then potential difference across C2 is V2 is equal to Q by C2, equation number 4. Then potential difference across series combination is equal to Q divided by CS. Then equation 1 becomes, ಇದನ್ನು ತಗೊಳ್ಳಿ, PS substitute ಮಾಡಿ Q by CS, P1 substitute ಮಾಡಿ Q by C1, P2 substitute ಮಾಡಿ Q by C2. Then Q common ತಗೊಳ್ಳಿ, Q by CS, Q 1 upon C1 plus 1 by C2. Then Q get cancels, 1 upon C1 equal to 1 upon C1 plus 1 upon C2, equation number 6. 1 upon CS is equal to multiplication LCM C2 plus C1, then CS is equal to C1 into C2 divided by C1 plus C2. It is the expression of effective capacitance of equivalent capacitance of series combination of capacitors. Suppose more than 2 capacitors you have to take, 1 upon CS is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 and so on up to 1 by Cm. ಅಂದ್ರೆ 2, 3, 4 number of capacitors ಹೆಚ್ಚಿಗಿದ್ರೆ ನಾವು ಈ ತರ ಬರೀತೀವಿ. This is about series combination of capacitors. Thank you.